Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. This podcast is the fourth episode in our 10-episode series called Unveiling Tech Horizons. Throughout the series, we will revolutionize AEC consulting by delving into cutting-edge technologies such as AI, BIM, digital twins, PM resourcing tools, and more. In this episode, I'll be speaking with Markus Weidner, the Chief Innovation Officer at Pennoni. We'll discuss how technology is normalizing and amplifying our human abilities. We also discuss the increasing amount of collision between engineering and systems design/architecture and the need for technology backgrounds in engineering. With that, let's jump into today's episode. Okay, it's now time for our conversation of the week with Markus Weidner. Markus, welcome. Thank you so much for joining us.
Thanks for having me.
Absolutely. So we'll jump right into it because we've got a lot of talk about today and some really interesting topics. But Markus, could you briefly introduce yourself? Kind of tell us a little bit about your background in the AEC industry and how you've gotten to your current role, which is the Chief Innovation Officer at Pennoni.
Sure. Thanks for having me on the show. My background, I guess it starts with my undergraduate education. I attended Temple University here in Philadelphia, and I was in the civil engineering program. And in the last few years, while I was in the program, I ended up doing a lot of work with the university computer department, ended up working at the College of Engineering itself. And that's probably the point where I started to really embrace the role of computers and technology, and frankly, my first job then was with the Philly Water Department. I gained a lot of experience with geospatial data sets, and we were in the kind of early days of putting together actual GIS type systems, and those early experiences really set me up for kind of a pivot from my profession of engineering to more of a pure technology role. So I joined Pennoni after a couple of years with the city, and I went through, we'll just say, a couple different gradual, upward movements as I, started running a small team, and then we, had a defined IT department, and all that was great because it was occurring at the same time as Pennoni's growth. We did a number of acquisitions. We're talking about the date range of like 1999 to 2010, and the firm went from the high 300s up to about 700 or so people. I actually left Pennoni and I went to work for a national architecture firm, and I spent a couple of years there as a director of technology, and it was really great because I got to see a completely different side of our industry. So that company had both architecture and interior design, and we were able to embrace a lot of the emerging technologies from Autodesk at the time, which would have been like Revit and Revit Server, which later became BIM 360. And then in 2017, I had an opportunity to rejoin Pennoni in a completely different role and capacity. That's the point where the company created the role of Chief Innovation Officer. So I rejoined, and my focus ever since has been on really, kind of a comprehensive digital strategy for Pennoni, as well as helping clients, create and adopt one as well. And I guess I kind of missed the point somewhere in the middle of all this. I went back and I got my master's in management information systems. So, I think that may come up later when we're talking a little bit about, what are some things that engineers can do to lean into the technology aspect of things. And I'd say I did it. I recognize the fact that there were some gaps in my experience and my knowledge, and the best way to correct it is go listen to smart people and force yourself to do some coursework and write some reports and do some papers, and that's what I did. And here I am today. I've been in this role now. I think it's 5.5 years, and there's a lot that we've accomplished. I'm really proud of where Pennoni is on the digital front.
And to the audience, right, Markus is bringing a very unique perspective because as we noticed, right, first this background in civil engineering, which, right, this is kind of where the podcast is centered on, right, in this intersection of technology that you spoke of. But kind of bringing it all together is Markus has got this, C-suite level position at Pennoni that has essentially responsible for a firm-wide strategy, right? So I just want everybody to pay attention because this is a really unique perspective that we haven't had on the show before. But Markus, could you talk a little bit more on the tech side, right? What are some examples of how engineering is colliding with system design and architecture?
Well, I think you could pick apart this question and lay it on top of any one of our engineering or scientific disciplines, and there's some sort of digital play. So I guess, the broadest sense, we're obviously in an era where the large majority of our designs are model based. And so, when you start to build models, you're creating digital twins. And the moment you have models, you've got, essentially a data structure, and you've got objects with complexity, and there's groupings, and there's object IDs. And what I think is interesting is that as we model out, the built world, we create these digital twins. We walk ourselves right down the path of being able to operationalize those digital twins, and then adopt all the sort of classic operations platforms that are out there, CMMS systems and capital planning systems. So I think, I guess I thought about this question ahead of time, and I thought, there's ways of doing things very simply, and then there's ways of doing things with an eye to, the long term, we'll say, asset life cycle. And I think to the extent that we think of either structures or horizontal infrastructure as part of a larger living system, then we're treating these as if they are part of, almost like organs of a body, because really what we're taking, the approach we're taking is much more of like a preventative care posture, right? So we're kind of like your physician, and so we're thinking of infrastructure as a system of systems, which is not unlike the way we view the human body and general health and wellness. And so, I think a lot of people are understanding now that there are ways of instrumenting and placing sensors and things so that we may understand, we'll say, seasonal fluctuations and changes in the condition of infrastructure, and then respond accordingly. And then to the extent that we can recognize signatures in the streams of data that we see, we're then able, through machine learning and artificial intelligence, to recognize patterns that may indicate imminent threats or problems, and then we can act accordingly. So I think it's really just understanding that we're now the master builders of large complex systems, and we've got incredible technology at our disposal. And so we as the engineer, we have an opportunity to embrace that technology and those technology platforms, and then help move our clients to a space where they're working with their portfolio in a much more proactive way. And I'm using a lot of generic terms because I think these principles apply to vertical infrastructure, so it comes out in the form of smart buildings. Obviously, it applies to horizontal infrastructure, your dry and your wet utilities that are all, heavily monitored and instrumented these days. And, they run, on sophisticated operations management platforms. So I think that in general, the answer to the question is it's colliding. It already collided years ago, and I think it's only today that a lot of our folks in our firms, and then our vendor partners are waking up to the fact that we too can take advantage of incredible technologies, just like the healthcare profession, just like a lot of other professions out there.
And just kind of simply put, based on what some of you've said, right? Like, no longer is it just a 2D set of drawings that gets constructed and that's the end of it, right? We're able to use the much more sophisticated technology that we have at our disposal to really look at the life cycle of these assets.
Yeah, and I think even the way that we're developing sites, we're using intelligent site optimization software to balance the site with regard to cut and fill. And then when the excavation plan is committed, it's going to a machine that's basically cutting the earth, using sophisticated location systems, like kind of reductive construction, reductive 3D printing, where the earth is the material. And so I think it's all changing pretty rapidly. And you're seeing that every module in the supply chain, has a digital version, has a digital path, and it certainly has a digital optimization. Even if it's computer based today, there's ways of going through successive optimizations and making it more computer based, and that's where we are. So I think the idea of systems engineering is really just the notion that we are architects of sophisticated interconnected systems, and generically speaking, there's always going to be some solution for each of those pieces, each of those parts and pieces.
We've talked a little bit about kind of the opportunities that this collision has provided, right? But what are some of the challenges you're seeing?
Well, I think that the challenges are that technology integration is still not something that uh, I, I'd say generally engineers don't see themselves as integrators, right? I mean, in my role as CIO and in various technology roles over the years, I've worked extensively with contractors and suppliers who sell a product and they've got integration, uh, basically boilerplates. They come in, they ask a bunch of questions, and then we go through some sort of integration engagement. And I think that that kind of project life cycle is not, it's just not something that's familiar to people in the engineering world, because engineers go through, and I went through this curriculum myself. You learn a lot of discrete subject matter, and then it's your job to sort of figure out how to put that all together. But really, it's almost always in the context of a design that has kind of like a finite start and stop and delivery, and you're sort of a part of a larger orchestration event that's going on. And I think that the challenge is understanding, or maybe better understanding the I guess the macro level implications of the design choices we're making. And I think that what we need is for the engineering programs to keep up with that. And I think that that's a challenge. I mean, I participate in a number of associations and roundtables, and this theme comes up again and again. And I'd say the biggest challenge is sort of the gap between the conventional, traditional understanding of what engineering is, and then the contemporary, modern version of what engineer is. Kind of like one of those memes. What I thought I'd be doing and what I'm actually doing, and what the architect wants me to do. And I think that kind of plays out. You think about that storyboard. While it's funny, it's very true. I think that the expectations are different than your expectations, and of course that's going to be like a moving set of grid lines too. Every year, new innovations, new disruptions come across. Excuse me, come out that we have to quickly absorb and understand, and then onboard into the process. So I'd say the biggest challenge would just be that the curriculum has to quickly evolve to respond to that. I think it also needs to include maybe a little bit more of an understanding of how different technology systems integrate. So if I were giving somebody advice about how to get the best undergraduate experience, I'd say find a way to minor in computer information systems or some equivalent, because I think that that's vital to the success of an engineer in today's world.
And there's this obvious need, right, for this intersection between engineering and technology, right? And you've kind of
Mhm.
talked a little bit about your path and how you got there. If we're talking about practicing engineers, right, what advice are you giving them to kind of prepare for this oncoming wave and the skills they're going to need?
Well, I think we live in, to me, kind of a golden age. Maybe I'll say that again in 5 years. I'll say this is the new golden age. But where we are today is that we've got incredible, vast, almost endless access to learning material. So the best thing you can do is commit to being a lifelong learner. Commit to maintaining a posture of curiosity, and I'd say be intensely interested in what's going on in the technology world, because while there are advancements in engineering, and your professional engineering credentials rely on you doing continuing education there. I think that to the extent that you can understand how the rest of the world is interoperating, that's going to lead to your own success. So how can an engineer? It depends on what I guess part of their career they're in. But if they're in school, then I'll go back to what I said before. I'd say find a way to get some coursework in database architecture, maybe operations management, maybe systems design, And whether you have to go back to school and get your master's, I mean that there's a lot of different ways to get those additional course credits and get that additional experience. But then, if you're practicing and you don't have the time in your schedule to go back to school, then I would say look at these and just find there's LinkedIn Learning and there's Khan Academy. There's a number of different places where you can get very basic, cursory coursework on all these subjects, and I think ultimately it's really helpful. I mean, I'm seeing so many places where people are talking about using Power BI, for example, and Power BI is it's kind of like Excel on steroids, I guess, or like a report building platform. And I think there's a perfect example of a platform where it kind of presumes that you have a basic understanding of data structures. I don't know any engineering programs, at least the era when I went to school, that had database design offered as a course. Yet, when you work your way through, and you end up, a practicing engineer or designer, there are going to be a number of different points where you're going to be dumped. You're going to have a data set dumped on you, and somebody's going to say, "Well, let's convert this into a report," and then you're just sort of learning on the job about things that you have to intuit. Um, so I guess that's kind of I guess one of many different approaches you could take. So in the educational sphere, there's obviously a lot of ways to tune your degree program. Universities these days let you customize your bachelor. So there's a lot of like nice sort of cafeteria style education programs that I think are a better fit for where we are now. And then if you're a practicing engineer, I think it's really just maintaining that curiosity, that posture of lifetime learning.
Yeah, and we try to be here at the Engineering Management Institute, one of those resources, right? So you can kind of figure out where to take your trajectory next. But a ton of great options available out there. And another topic I'd like to get into is artificial intelligence, right? So
Hmm.
all over the mainstream media, right? LLMs, Chat GPT, everything just exploding in the public's eye over the past year, right?
Hmm.
Could you talk about some of the potential applications to engineering that AI provides?
Uh, so it's a great topic because you're right. Everyone is talking about it. Every conference I go to has some sort of AI track, or at least a number of sessions get devoted to AI. But the funny thing, and I talk about this with some of my peers in the industry, is that if you watched what's going on, you'd think AI just hit the shelves, 6 months ago. Uh, but the reality is, people have been developing language models for quite some time. IBM had their very famous Watson project for, I mean, it feels like it was a decade. Um, so AI has been around, and I think it's both mature and immature. And I think it's mature in that we're at I think the threshold of ChatGPT 4.5. You're seeing Bard roll out new features, and that's on top of already really robust language models. I think Bard has 550 million parameters in it, or 550 billion parameters. So I think on one hand, this is a market that is based on years of research and years of methodologies. But then at the same time, I think the way that we integrate it into our lives is still really new. Yeah, so it's kind of an interesting opportunity because for those who are able to find ways to become early adopters and utilize the technology, they do have this small window of time where they could sort of jump out ahead and use it as a really innovative force in their firms. And I guess the question is, what are the opportunities? So I think that there's a lot of confusion about what the different terms mean. Artificial intelligence is, to me, more of an umbrella term for a lot of different technologies. When you use robotic process automation, which is, essentially like macros from the old days, you are in a sense using some artificial intelligence. You've pre-programmed a number of steps that can take place, upon a trigger, right? So I think that RPA, that's been around for a while. People are using RPA. Now they're calling it AI, but really it's templating out a number of actions that can create efficiencies, And then in a sense, this is also like machine learning, and machine learning is similar to the way that language models get trained. So taking a machine through many, many scenarios, with little like A/B tests and selectivity, and creating kind of a mesh network of decision support data, so that when the machine learning object sees a picture of a coffee cup, you've trained it on a number of coffee cups, it's able to say, hey, I just saw a coffee cup. And now you're seeing the practical use of these. I mean, they even make like consumer grade apps for the iPhone where you can point it at let's say a pile of stones, and it'll give you an approximate number of stones in the pile, or pounds, or rolls of paper on a shelf or something. So you're seeing like really simple, almost silly ways of using artificial intelligence, and I'd argue that that's really just machine learning, all the way to very sophisticated ones. And I've got a couple examples I thought about. So we do a lot of pavement programs for clients, and in the old days, it required a lot of manual driving around, what you call, visual site assessment or visual surveys. And, we now utilize technology where we capture video, so we drive, a network of roads, and then we utilize a system that uses machine learning, and then that system recognizes cracks and types of cracks, and geolocates them on segments, and then those aggregate up into larger segments with scores. And then by doing that, you're able to really like grade the quality of each roadway surface discretely. And then depending on how you want to break it down, and you want to view complete streets and then assign percentages, then you can utilize that information as part of an operations program and say, okay, instead of relying on complaints or 311 calls, we're now going to adopt a methodology, and the methodology is going to be data based. Now, is that artificial intelligence? I don't think so, because at some point the human is going to intervene, and the human is going to interpret the data, and then is going to sit with decision makers and say, okay, we've got 3,000 miles of road network, and we found out that 30 miles of it are grade 5 tire poppers, lots of potholes, lots of problems. And so we're going to recommend that we go after these 30 miles. You have 50 miles in your program, so we have another 20 miles. We could prioritize, and look at the 4s and the 3s. So I think the artificial intelligence, I guess, is the part that is the machine learning. And it's the computer or the robot looking at volumes of data, and drawing conclusions and doing these interpretations. And frankly, that is the incredible potential of the technology. It's the ability to make the robot do something that would take humans, weeks maybe, to do so thoroughly. Like humans could do it, but they'd be more selective in the process. But when you assign it to the robot doesn't care if it's 3,000 or 30,000. It might be the difference between 7 minutes and 14 minutes. But compared to the human effort required to do the same thing, it's de minimis. And so I think that's where some of the promise is on scale. Some of these larger exercises where we collect volumes of data manually, where they come in through sensors, we can act on them now on scale. And, to the extent that you've got machine learning that's looking at predictive analytics and understands behavior, strength of materials or life cycle of piece of equipment, you can then trigger these, preventative maintenance events, or preventative maintenance through replacement events. And I think, to me, that's where artificial intelligence comes into play, is that it's certainly not a replacement for humans. It's a companion technology. And I often use the term amplifier or accelerator. To me, I think it's a human accelerator. And the metaphor would be, I think a number of years ago, the first e-bikes came out, and people said, "Oh, that's terrible. People should, use their own pedal power to get around." And I kind of felt the same way. And I thought, well, yeah, it's kind of like cheating, using the e-bike. But now, is there a city in the U.S. or in the world where you don't see delivery drivers using e-bikes? And I think the idea is, if you think about it, you shorten the trip time, you can get more deliveries in, you can get more food into people's hands. So you see all these DoorDash guys on e-bikes. Why? Because they're able to move through, a book of deliveries a lot faster than if they were just riding around on their own bike. So, that's an example of where it's a human still in charge of making the final delivery, but the human is experiencing an acceleration as a result of the e-bike. And to me, AI, co-pilots, and we will see many of them roll out in the next year. They're all, mechanisms by which we can accelerate our own movement through, our project backlog.
And And the way I like to refer to it in these types of discussions is, right, it's like donning the Iron Man suit, right? It's ultimately the person that makes the suit, but the
Mm.
capabilities it would give you is incredible, right? Tony Stark and movies. And
Yeah.
some of the examples you brought up are great. And speaking personally from someone who's, in an inspection based industry, these computer vision based softwares, right? We've had a couple come on the show to help essentially prioritize maintenance of built world assets, right? It's
Mm-hmm.
it's amazing how the promise to shorten that time frame, which would otherwise take human inspectors a long time to do. But the other question that pops up a lot, especially as you start getting into some of these programs, are the ethical considerations, right? Because it's not just a calculation that you're checking by hand or a junior engineer that you're
Mm-hmm.
mentoring and kind of advising, right? You've got sources of data coming in from all avenues, right? You may not fully understand all of it, but there's got to be some way to essentially provide the same level of competency and standard of care as professional engineers, right? So could you talk a little bit about the ethical considerations that engineers should be aware of when using AI?
Well, I think they're still under development, right? So I think the way we use AI is, let me think of a good way to put it. It's in draft form. How about that? So we are by no stretch of the imagination at a point where we know exactly what A, the limitations of AI are, and B, where we draw those demarcation lines between the computers and robots and humans. Um, and our posture, and I think it's shared by many firms in the industry, is that AI is no different than many other technology tools that we've used in the course of project design. And uh, the work needs to be checked. It can't be viewed as a primary source. And in general, I think there are very few examples where we're just giving over control of a design to AI anyway. So, there's still provenance, right? Humans are still in charge of the design, and certainly once it gets the stamp of a professional engineer, that professional engineer is taking all we'll say the aggregate of all the different efforts across a number of different people, and whether they were aided by analysis software or they were done by hand calculations, the PE of record is still the person who's viewing all of that in totality and then, agreeing and stamping and signing it as something that's ready for submittal. So I think, the ethical considerations are only considerations if you are I just say inappropriately assigning responsibility to AI. You shouldn't be taking the output of Claude and copying it and pasting it into a report to the client directly. That's a form of plagiarism. I mean, can you use it as some seed information and work with it? Perhaps, but I think most firms out there are going to say, we're not using AI as a primary source. It's not Wikipedia, and how do you create citations to something that's coming up with information based on language models that are based on training, that are based on the contents of reference material that we don't have the ability to verify and understand. So I think that's where it's going to get a little bit tricky, is that you're ultimately going to need to know, hey AI, where did you get this information? Can you provide citations? And some of them can, and some of them can't. For example, Bard will give you some citations. I think Pi will not. Pi is from inflection. Pi will just be kind of roundabout and say, well, based on the materials that I've access to, this is the best information I have. But if you say specifically what journal is that from, they'll be evasive. And so to me, I think that's where the ethical considerations come in. It's kind of like, you know, shady unnamed sources for news articles. You got to know where it came from, and there's got to be some sort of provenance to it.
And kind of jumping off that point, right? Like being able to, verify sources and essentially as the engineer of record kind of compile it all, right? That's a skill in itself. But over the next, couple of years, even looking further ahead, what are some of the most important skills that you think engineers are going to need to have to succeed in this new era of technology that keeps coming at us?
I think probably this is going to sound repetitive, but I'm going to go back to some of the earlier comments I made about strengthening the curriculum. So if the engineering program um, hasn't added that additional, extensive study, then I'd say it's up to, the student, or you do it in your graduate program. Because to me, I think that is vital. I mean, are there going to continue to be very compartmentalized roles where there are very specific design tasks that can be performed in isolation? Absolutely. But I think increasingly, the value of the engineer, especially in a climate where, we're talking about, and we didn't really get into it today, but I think earlier you were mentioning that your firm does some work with parking structures. The use of industrialized process is skyrocketing, right? So you're seeing a lot of things that are being prefabricated in factories, and they're shipped, and then they do final assembly. I mean, this whole movement towards tiny homes, really is fueled by the ability to manufacture parts of homes and bolt them together. I mean, we used to call them trailers. Now they call them prefabricated homes because there's no stigma attached to the fact that you can have a very nice home arrive on a couple of different tractor trailers and then put them together. So in that scenario, and if you apply that to bridge building or construction of a parking garage, as more and more of this becomes Lego type of exercise, then the real question is, well, what's the role of the engineer there? Obviously, somebody engineered the panel, but the engineer did the design once and then sent it off to manufacturing, and now they've got a template for a certain you know 8-story parking garage that they can rinse and repeat over and over again. So the engineering work sort of gets reduced in complexity to some extent. And so what's the value? It's the communication skills. We're seeing a lot of opportunities to use our digital twins to help our clients pitch a project to the community. So I'd say public speaking, communication, the idea of understanding, the context of projects, so the social consequence of things. And I think a lot of that is now coming out in the way that infrastructure projects are being planned and scored. So I think the engineers of tomorrow, they've got to build out these two other, legs of their stool. They've got this great technical understanding of the fundamentals of engineering, and that comes from excellent coursework. But then the other two are going to be, a kind of social awareness and an emotional intelligence that lets them communicate with peers and partners, and then constituents and customers, as well as a technology understanding of the way that all these sophisticated systems, interwork. And so to me, I mean, I didn't talk much about the sort of the social and the communication side of the profession, but I think it's vital. And you're going to see greater success if you can talk to clients and have kind of a command of the language in layman's terms that helps put their mind at ease that this project is not going to destroy the view shed, or it's not going to introduce an unruly amount of traffic into the state road. Because to me, those are often the obstacles to getting permits approved and getting our clients' projects built and constructed.
Markus, you said it. I mean, the three-legged stool and these topics beyond just the hard technical topics that we're learning in university, right? And the Engineering Management Institute, right? A great place to come for all things, soft skills, communication, right? This podcast for technology. There's other content on there, and like how to, prepare for your FE or your PE, right? So we're trying to help that cause and kind of be that one-stop shop. But Markus, again, it's been a pleasure having you on. But as we conclude the conversation, what advice would you give to engineers who are in a role and say, hey, I'd like to maybe one day step into a position like Markus is? Like, what would you tell them?
Spend a lot of time building up your thick skin. To be honest, a lot of people who take on technology leadership roles in our industry came from some part of production in their company. And what ends up happening, and in the old days, it was the person who had the most interest in computers, maybe the gamer in the room, and they'd be the ones who are responsible for setting up computers. Well, that worked, I think, 10, maybe 15 years, 15, 10, even 5 years ago. But as the role of technology leadership in our firms has changed, I'd say that it's not just being interested in computers and technology, because we at this point can buy desktops as a service, right? There's DaaS out there, there's VDI. So I think even the complexity of technology has shifted, and it's very much everything as a service, and it's compartmentalized, and frankly it's turning into sort of like utility computing. So I think if someone was interested in becoming a CIO today or a technology leader today, it's understanding that some of those old fundamentals, much like the engineering, profession, engineering design profession, those things have been compartmentalized, and now they're sort of built into higher level packages, right? You heard of low code development, right? So you can develop these quick little apps, and they call them low code because all the drudgery of creating, little stored procedures and functions and things like that, that's already been done for you. So you're going to build something out of a kit of parts. It's kind of like, Lego for developers. And I think that technology is similar to that. And, at some point in the future, engineering will become more like that as well. So my advice for somebody would be have the situational awareness to know that things have changed, and they will continue to change. And if you want to be, part of a group of people who are on the leading edge of bringing change into the organization, don't just view it through one lens. Obviously, there's technology, but you use that term, and I like it. The three-legged stool. It includes communication, and it also includes this notion of we'll say human context, and putting all of these things in the context of real human needs and dreams and desires and things like that, because I think that's where the successful marriage of technology and process results in results in something that's measurable and real and useful. And and I've learned, a lot of this you'd learn on the job through some failures or some mediocre results from project implementations. But I'd say the best projects have had, great stakeholder groups, and a great technology leader is going to understand that you need to build some consensus. You have to have some people with a vested interest in the outcome. And frankly, that approach applies to just about any major initiative, whether it's a project coming out of the ground or an implementation of a major technology system, or swapping out the supply chain software for a manufacturing company. They're always going to, I'd say, drill down to the person on the product line, the production line, who has to interact with it every day, and understanding, what their issues are and their needs are. And so I think that's where the communication skills and, I don't know, the human factor engineering aspect of this all come into play.
And, we talk about it all the time, right? The easy part in any, let's say enterprise software rollout, right? It's picking it, figuring out how to use it. And then that's the cakewalk. And then when you get to rolling out to users, right? That's the most challenging but rewarding, really, part of it. So it's always being able to interact with the people in an effective way that, like you said, it doesn't matter if it's technology or anything else. That's always going to be most important.
Exactly right.
But again, Markus, thank you so much for joining us today. If our listeners want to connect with you after the show, what's the best way to reach you?
Oh, well, they can reach me at mweidner, MWEIDNER, at Pennoni.com, PENNONI.
Excellent. And for everyone who's listening, that'll be in the show notes, so no worries if you don't have a pen. But Markus, thank you again so much for joining us today.
Sounds good. Thanks. My pleasure.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.